let me do this and let's see if we can get this connected. Alright, so there's my boundary line for this inequality. We're not done yet because we have to shade. So if the symbol is less than or equal to, do I shade on top of the line or below the line? Well, if it's less than, that means we shade below the line. So, let's see what we can do here. We're going to shade below the line. So you guys always see the colored pencils on my desk, and a lot of you like to write with them. Well, this is the whole reason why those colored pencils sit there, is because I know for a fact that eventually you're going to have to color. So you can use your pencils, that's fine. Feel free to use your colored pencils there on my desk if you would like to as well. Alrighty, so let's do a couple more examples like this. Alrighty, so here we go. We've got 5x plus 2y is greater than negative 8. Well, first things first on this one, we've got to make sure we're in slope-intercept form, which means we've got to get that y all by itself. So the first thing we always move is that x over to the other side. It's positive right now. We have to subtract it to move it. Move it to the other side. Let's rewrite what we have. We have 2y is greater than, and I'm going to put that x part first, negative 5x minus 8. Last but not least, we got to get the 2 all the way by itself, or the y all the way by itself, which means we have to get rid of that 2. So we're breaking it apart. That means we divide, and then everything else has to be divided by that 2. Now the slope, that negative 5 over 2, that cannot be simplified at all. So I'm going to leave it negative 5 over 2. Remember, fractions are good with slope. Now we've got negative 8 over 2. That one's an easy simplification. 8 divided by 2 is 4. Alrighty, so now that we're in slope-intercept form, let's start graphing. We want to start with first that negative 4. So that tells me that my intercept is on the y-axis at negative 4. I wonder. There, right there. Perfect. Now, a slope of negative 5 over 2 tells me I can go down 5, right 2, but notice that's going to pull me clear off the graph. Okay, so it would be somewhere like right there. Kind of hard to see. So let me go the other way. I could put that negative on the bottom instead, and I could go up 5, and then back 2. So roughly right there. So I have enough dots there now to make my line. So we need to look at what symbol my graph is calling for. There it is. Is it equal to? No. So because it is not equal to, what kind of line am I going to have? Dashed. So we do our best to dash. It's going to be a little crooked, kind of hard to do on this thing. Okay. Can't be any worse than my drawing by hand. Alrighty, so we've got a dashed line now connecting our dots, our points. Okay, and last but not least, we have to shade one side or the other. Now, what symbol is that one? It is greater than. So if the symbol is greater than, do I shade the top or the bottom of the line? That is right, we've got the top to shade. So the top of the line is right here. Alrighty. hope this is kind of clicking and you guys are all paying attention here. Okay, I'm going to skip. No, this is a good one. Okay, so here we go. We got to get this into slope-intercept form, which means we've got to get that y by itself. So let me change my pen color. There we go. All right, so first thing we're going to move is that 4x to the other side. So if I move the 4x, bring it over here, I now have negative y plus 2 less than or equal to negative 4x. Next, I need to move that 2, so we subtract the 2. I have negative y less than or equal to negative 4x minus 2. Now, the one thing, if I would have actually done the section on inequalities with you, or the chapter on inequalities with you, one of the things that you would have learned is that this next step is very vital on how you do it. The y is not by itself yet. You've got to get rid of that negative. You've got to move it to the other side. So most of you know that you could either, one, go through the whole inequality and change the signs, or we also think of it as dividing by that negative 1. So if I divide everything else by negative 1, okay, you end up with y. I'm going to leave that symbol alone for a minute. Negative 4 divided by negative 1 becomes just positive 4x. And then negative 2 divided by negative 1 is a positive 2. Now, here's the most important part. Anytime you have to divide by that negative whatever, it could be a negative 4, negative 10, the important part is that you see it is a negative. When you divide through by a negative, you have to flip the inequality symbol. So it now looks this way. This right here is what you're graphing. Y is greater than or equal to 4x plus 2. Alrighty, so here we go. Intercept at positive 2. Just imagine it's over a little bit. There we go. Slope of 4 means we can go up 4 over 1 or down 4 back 1. Okay. My line, solid or dashed, it's all based on that inequality. So because it is an equal to, greater than and equal to, we have a solid line on our hands. Alright, last but not least, a shading. If it is greater than, do I shade the top or the bottom of the line? Well, I hope that most of you said the top, which means we shade this side of it. Alrighty, here we go. Okay. Last but not least, you have to be able to take a picture or a graph that's given to you and tell me what the inequality is based on that graph. Okay, we've actually done this before as well with equations, but this one has a little bit more information that we've got to figure out. Now, we know that every inequality that we'll be dealing with will be in slope-intercept form. So we'll have y, oops, let me erase that, switch back to my pen. We'll have y, some symbol, mx plus b. So I'm going to go ahead and take care of the easy stuff that we know how to find already. The y stays, and we know the x stays. But the b is the y-intercept. Where does it cross that y-axis? Right here. At what value? Positive 1. Now, to figure out the slope, you need to look at this line real close and see where it hits the next like perfect coordinate point intersection on it. And if you notice, it's not until you get clear down to this point right here. Alright, so now we got to figure out our slope. Rise over run. How far up, how far over do we have to go from one point to another? Well, if I start with the point that I chose down here, I have to go up 1, 2, 3. So I got to rise 3, and then I run 4. So far we're doing pretty good. The only thing we have left now is the symbol. And the symbol is based on the type of line that's present and where it's shaded. So the shading tells me what? What part of the line is shaded? The top part of it. So your y has to be greater than that rest of the equation or inequality. Okay? And then we need to check and see if it would be an equal to or not. Well, notice that we have a dashed line. So is it going to be equal to? No. So the equation or the inequality of the graph shown is y is greater than 3/4 x plus 1. Alright, next up we got one more example here, and then I'll let you guys get busy with your work. Write an inequality to represent the graph shown. So this one's just like what we just did on the last slide. We've got to do the y mx plus b. Remember, y is always there, and remember, x is always there. So now let's start with our intercept. Now notice this one's just a little bit tricky. I don't remember if any of them on your papers are this tricky or not. Look at where that intercept is located. The only reason it's going to be tricky is because of the way they have these, the units labeled. So notice each little line is a 2. So if I'm directly between -4 and -6, where is my y-intercept? At -5. Okay, so now we've got to find slope. Well, if we know the intercept's -5, and we know every line is 2, so if I go from my intercept up 1 and then over 2, so if we go up 1, over or back 2, so your slope is -1/2. It's really tricky with this picture, I know. Okay, so now let's talk about the shading. We got the shading, and the shading is underneath of the line. So what kind of symbol, what kind of inequality do I have here? It's going to be a less than, because the shading is underneath the line. And last but not least, we need to look at if it's going to be an equal to. And how do we determine that? Based on if my line is dashed or solid. If it is a solid line, then we know it is an equal to graph. So we got to have that little bar there. Alrighty, so hopefully I've given you enough information and examples for you to refer to as you're working on your worksheet. Good luck. If you have any questions, make sure you email me, Mrs. Webb, prctc@gmail.com. I'm pulling for you guys, so just do your best. Hopefully we'll continue through this, and I will talk to you tomorrow. Alrighty, good luck.